Scalars and vectors next, if you want to write that down. So that's our second lesson, scalars and vectors. Oops. There was a really good show, I think it was made by the BBC, and it was all about the 7 base units and their definitions. So I don't know, but you know, some of the units, like for example, the second is defined as how much time, which not only the definition. See, all these units, huh? Yeah, like all these units have definitions. So like for example, like if I said how long is a meter, then the definition is a meter is the length of distance light travels in. You know what I mean? Yeah. And then the second is the amount of time for a particular atom to vibrate. What atom is it? I can't remember right now. So you have all these different definitions, but the kilogram is the only one that's defined by some physical thing. So a kilogram is still defined as the mass of the 1 kilogram prototype in France in the museum. You know what I mean? So I found it amazing that every year they take the kilogram out of the safe and then they make careful copies, like 100 copies of this, and then they send a copy to each country, and for each country that is that's officially what a kilogram is, you know, in that country. So I'm sure somewhere in Ireland, in some place there's in a safe 1 kilogram, and then whenever a measurement has to be made or a weighing scales has to be made or something like this, then this is the only official kilogram. I thought it was really interesting because all the other definitions you don't need to have access to something, because you know you will have access to light and things like this. Whereas the kilogram, it's still something that is sitting in a safe somewhere, and this is the only official 1 kilogram. It's made out of platinum and iridium, and basically they made it and said, okay, this is what a kilogram is called, about 150 years ago. Originally a kilogram was supposed to be 1 litre of water, but the problem is, the problem is 1 litre of water changes on air pressure, impurities, altitude, temperature. It's not really a good definition. 1 litre of water changes too much. And did you know what originally 1 litre was? What? It was, the original definition was from the equator to the North Pole was to be 10 million meters. This distance, but of course you can see why that definition is not useful. In fact, the reason it's not useful is because you know the Earth's shape is always changing slightly, so it's not, it's not really constant. Like for example, if the the North ice caps are melting, so it will shrink the distance a little bit. It was a really good show. I'll try and find the name of it. Okay. But I think you should watch it if you can.
An hour documentary.
Yeah, there was 3 hours. One. So each the first hour was about meter and second, and then the next hour was about, I think it was kilogram and mole.
Okay.
It's broken down like this. Anyways, I'll try and get the name for you. It was a really good show. Yeah, I'll try and get the name. BBC always make good, BBC, don't they? They always make good documentaries, really good. Okay, so the first definition, would you know what a scalar is? Have you heard this word before?
Yeah, scalar quantity and vector quantity.
Yeah, scalar and vector.
So vector has magnitude and direction.
Yeah.
Scalar is just magnitude.
Yeah, so scalar is a quantity that has only magnitude and no direction. So for example, walking at 1 step per second is a scalar. However, walking at 1 step per second to my home is not a scalar. Why is it not a scalar? My second example.
Because that's your home has a direction.
Yeah.
From the spot you are now.
Yeah, so there's a direction in it, which makes it not a scalar now. Okay, so the next thing then is vector. So a vector has a magnitude and direction. So for example, walking at 1 step per second to my home is now a vector, and 1 step per second is not a vector, it's actually a scalar. And of course, these are very common exam questions asking students what is the difference or the definition of a vector and a scalar. So very traditional exam question, scalars and vectors and the difference between them. Okay, you got this definition? Yep. Okay. So the two most well-known examples of scalars and vectors are speeds and velocities. So most native speakers would say speed and velocity mean the same thing, but they don't. In fact, they're two different things. So we'll just be clear about each of them now. So definition: speed is the rate of change of distance per unit time. So as a formula, you could say, for examples, you can say 50 kilometers per hour, 10 meters per second, 1 step per second. They're all speeds. So as a formula, you can say speed is distance traveled divided by time taken. Got that, yeah? Okay. So actually, before I go on, would speed be a scalar or a vector?
It's a scalar.
It's a scalar, yeah. There's no direction here. Now, velocity is the rate of change of position, also called displacement, travelled per unit time. So, for example, 50 kilometers per hour due north, or 10 meters per second to the finish line, or 1 step per second towards your home. They're all velocities. So as a formula, velocity is change of position over time taken. So this one now is a vector because there's direction. Okay, so if I throw something to you at 1 meter per second, is that a scalar or a vector?
It's a scalar.
Is it?
It's a vector, unless I'm moving in circles with it.
No, it's a vector because I said, I was trying to trick you. I said if I throw something to you,
Okay.
The to you is the direction, yeah. Whereas if I just said I throw something at 1 meter per second, that is a scalar. Yes, I tried. It's just tricky. That's all. Okay, so that's velocity. No, I guess that's a pretty formal definition. Right. So just to be clear, since we were talking about displacement, displacement is a vector, and it's the position of an object at a point in time. That's how I always think of it. So, for example, you could say the ship is now 2 kilometers to the east. That's a displacement. That's a position. Or the ship will be 3 kilometers to the east in 1 hour. That's still a displacement, even though it's in the future. It's still a position. It's still a displacement. So just to be clear, displacement is a vector. Okay. So terms like homebound and to the finish line, although they're directions, they're not mathematical. So homebound to the finish line, they're not mathematical language. We need something more precise. So often vectors are given as a magnitude and an angle, which represents the direction. So for example, you could say 10 kilometers an hour northeast. So the 10 kilometers is the magnitude, and the angle northeast is 45 degrees. So you can actually represent this as an arrow. So when you draw an arrow, you're drawing a vector. So the magnitude is the length of the vector. So if I say 10 kilometers per hour, that's the length here should be 10 kilometers per hour. And if I drew a vector of 20 kilometers per hour, it should be twice the length. And the direction is represented by where it's pointing. This is called the tail of the vector, and this is called the head of the vector. So the length represents the magnitude, and the where it is pointing represents the direction. But this vocabulary, I'm sure you might know already, but at the very least, you could draw this diagram for tail and head and magnitude and direction. So just copy this down, this diagram here. Yeah, great. Okay, so let's have a look at some examples here. We want to draw these vectors. Okay, so the first one.
Am I going to need a projector for this?
No, we're not going to be that accurate, just roughly. So the first one, we want 5 meters per second due north. Okay, so for my diagram, I'm going to say this is roughly 1 meter per second, so 5 meters per second, very roughly. That would be the vector there. Okay. Next one, 4 meters per second due east. So, what's that? To the right, yeah, and a little bit shorter. So, I don't know, about maybe this much, roughly. Okay, I'll just give you a minute to draw these before I do some more.
Just copy this.
Yeah, I'll do some more now. Go up to H. That's A and B. Okay. C now. C is 5 meters per second west. Can I go down a little bit? Yeah? Do you have the first one?
Just a minute.
Sure.
Okay,
Yeah? Okay. So 5 meters per second west. So that one would be a little bit longer, like this. Okay. And then 1 meter per second south would be something like this.
Well, like,
Mm-hmm.
in vectors, right?
Yeah.
It's magnitude and direction.
Yeah.
So the magnitude can be anything, right? Not only speed.
Oh yeah, the magnitude can be any dimension and unit. Yeah, yeah. So I mean, in my examples, yeah, I did use speed, but as the magnitude. But you're right; it could have been could be force.
It
Could
could have
be.
just been 1 meter, right?
Could have just been 1 meter. Could be anything. Yeah, anything. Okay. Do you have these so far? Right. So the next one now, E. So again, a little bit trickier with the English now. If I said 3 meters per second, 30 degrees north of east.
Doesn't it just mean northeast?
Well, I mean, where would you draw the 30 degrees? Like, in other words, should you measure the 30 from east, north, west, or south? And should you go up or down? Left or right? So what do you think?
Does north of east
Yeah.
mean northeast?
Not quite.
Okay, so you're supposed to measure it from east
And do you go up or down?
or down.
Go up.
It's supposed to go up.
North of east.
Oh, okay.
Yeah.
I get it now.
You get it? So, for example, if this was east,
Yeah.
then you would have the vector like this. That's a bit too long, maybe. 3 meters per second, and this angle here
It's 30 degrees.
is 30 degrees. North of east, yeah. Okay, have you seen? Oh, I'll give you. You need a minute?
No, I've had that already.
Okay. So, have you seen that one before? North 30 west.
No.
This is a new one as well, yeah? So, here. We start at the north and go 30 to the west. So this is 3 meters per second.
Okay, so it's the same thing as the other one, it's just the arrangement is a bit different.
Yeah, basically, yeah. So this would be 30 degrees west of north.
Yeah.
Okay. One meter per second. Very good. Which way?
Right. It's
Yes.
always clockwise.
Yeah. So this one here would be a little vector, and the angle here is 30 degrees. So this one you've seen before.
And this pitch is also the same thing as the other one, right?
Which one? Is it?
Same as G, but it's a bit longer.
Well,
Is it not?
I don't know. I think this one here, I would draw it like this, because by using the at,
It's horizontal.
yeah, I suppose I'm trying to make it more like just a mathematical. Mathematically, where do you measure angles from? You measure it from the x-axis and you go
We
up.
always measure from the north, right?
Well, you always measure from the north when you use the word bearing.
Okay.
So the word must be there. Whereas if I just said, oh, it was at an angle of 30 degrees, like forget about physics and vectors and maths. If I said, here is your xy, draw 20 degrees, would you draw it up here or would you draw it down here?
Down there.
Yeah, down here.
But you can also draw it left, right?
No, actually, because that would be like, 160 degrees.
Oh, okay.
Yeah, now if it was a triangle, yeah, I suppose they're kind of the same. Anyways, we don't usually use this because it's not so clear. But if I had to pick,
So it's always from the first quadrant, right?
yes, from the X, yeah. If I had to choose, I'd rather choose this than the other one here.
Yeah.
Yeah, if I had to choose. But usually we don't have to worry because the question would have the angle drawn on a diagram.
Okay.
So it's not going to be a problem for us. Okay, yeah, got that? Alright. So this second lesson is a lot easier than the first lesson because we've already covered everything we need. And these questions are quite short. So I'm confident that you'll get them all finished now actually, because they'll only take a few seconds to do each question. In fact, I think the first question is the longest where you have to explain the difference. But the other questions you just have to say if it's a scalar or a vector, and then in number 3 you just have to draw them. And you can see in number 3 I switched now to using meters instead of meters per second. So for example, you could say maybe let 1 centimeter be equivalent to 1 meter. Have you got a ruler? Yeah, so don't worry about measuring the angles, but at least have the length correct. Yeah. Okay, I think you could probably do these in 5 minutes, and then if you want to give 5 minutes to the other questions, and then you can have all your homework finished for tonight then, which is good. This won't usually happen. Usually you don't have time, but because there's only one student here, there's not really many questions to go through.